Okay, my seventh graders, sorry. If you weren't in tutoring for the real number system, just come by in tutoring and see me. But this is the properties of real numbers. We already know what the real numbers are. They're any number that we're going to deal with in algebra. Most of these you've seen before, but we're just going to go over them. The first one is commutative property. Commutative property is where the order of values does not matter. So think about what the word commute means. It means going from one place to the next. There's two girls in here and they're being crazy. From one place to the next. So if you imagine 5 plus 3 equals 3 plus 5. It doesn't matter the order in which I add them. The value stays the same. I think most students just want to look at something and think, oh, this has got to be a property. But remember, this equal sign means equality. So always check, does 8 equal 8? And in this case it does. Commutative property checks out. You also have commutative property of multiplication. Again, it's the same thing. You can say 5 times 3 equals 3 times 5. But equality has to remain the same. 15 equals 15, it checks out. So the big key here on commutative is that your order doesn't matter. So that should fill you in the notes there. Our next property that we're going to look at is the associative property. Associative property says the grouping of values doesn't matter. So again, equality is key. So if you have 3 plus 5 plus 8, my order is going to stay the same. It still is going to be 3 plus 5 plus 8. But what I mean by grouping is that I can do 3 plus 5 first, or I can do 5 plus 8 first. But my grouping doesn't matter. And again, I'm still going to check for equality. 8 plus 8 is 16. 8 and 5 is 13. 13 plus 3 is 16. So it checks out. So that holds true. You also have associative property of multiplication. So when we multiply 3 times 5 times 2 equals 3 times 5 times 2. Notice the order is the same, but my grouping has changed. And again, I'm just going to check for equality. 15 times 2 is 30. 10 times 3 is 30, and it checks out, so it holds true. That is the associative property. All right, my next one is the identity property. Think about it. If I look in the mirror, who am I going to see? I'm going to see me. So whatever you begin with, you're going to end with. So the key here is that it stays the same. The value stays the same. So if I begin with me, what do I have to add to get me in the end? I have to add a 0. Okay, so that's the additive identity. The multiplicative identity would be, what do you need to multiply by me to get me in the end? 1. So stays the same. 5x is going to stay the same on the other side. 4 is going to stay the same on the other side. That's that identity property. My next property is inverse property. Did you want to take your quiz, April?
Yeah.
Okay.
This room is not here, and I couldn't do my science until
Okay, so hang on, guys. I'll be right back. So pause it or fast forward. That's right. Okay, I'm back. So my inverse property is that we are using opposites to cancel out. So inverse is a synonym for opposite. So when you look at inverse properties, you see this. I want you to highlight it because you see it in multi-step equations. It's all over the place. In fact, in multi-step equations, you really just use 2 properties. You use multiplicative inverse and additive inverse. So all it is, it's canceling out to 0. So if you see 5 minus 5, that equals 0. Notice they're opposites. One integer is positive, one integer is negative, and they cancel out to 0. You can also do the multiplicative inverse. So all you're saying here is you're going to multiply by the inverse to get 1. And the inverse of a fraction is where you flip it to be 2 over 1. Okay, so that's the multiplicative inverse. Let me show you that as a 2-step equation. So if you have 2/3 x minus 5 equals 10, my first step here would be to get x by itself. So I'm going to add 5 on both sides. This right here, because I need it to equal 0, so that is my additive inverse. And now I have 2/3 x equals 15. Multiplicative inverse is what allows me to get x to be equal to 1. So I'm going to multiply both sides by 3/2, and watch what happens. When you multiply by 3/2, my 3's cancel out, my 2's cancel out, and I'm left with 1x. So x then equals 45/2, and that would be my answer. So inverse property is what you see all the time with multi-step equations. My next property is property of 0. Property of 0 is almost too silly to even be a property. We know of means multiplication in math language, so all it's saying is multiplying by 0. Well, don't we all know what happens when you multiply by 0? Multiplying by 0 always equals a 0. So whether it's 4 times 0, you get 0. Whether it's 3x times 0, we're going to get 0. Whether it's 3x to the 4th, y to the 3rd, z over x to the 5th times 0, we still get 0. Multiplying by anything is going to get me 0. Distributive property, all it's saying is that you are multiplying a value to an expression inside parentheses. I know you've seen this. We did it at the Figure Me Out beginning of the year. So if you have 2 times x plus 4, you have to distribute and multiply 2 times x, which gives me 2x, and 2 times 4, which gives me 8. And so that would be me using the distributive property. And I know you guys have seen that before. Okay, so these should be common review, these 6 properties right here. If you flip the page, we're going to go over 3 new properties. Again, you're not going to see these properties until geometry, but we're going to talk about them in algebra. So the first property that we're going to talk about is reflexive property. And all that does, it says if A equals B, no it doesn't, I messed up, I'm thinking symmetric. All it says is a value equals itself. That's what that one says. A value equals itself. So what would that look like? Any value for equals itself. Reflexive. So you can say 5x equals 5x, 1 equals 1, 2x equals 2x. It equals itself. The reason we use reflexive property, and usually it's just in geometry, proving rectangles congruent, is if you're proving triangles congruent, not rectangles. If I want to use this rectangle and prove that triangle ABC is congruent to triangle CAD, CDA, then I know that AB is congruent to CD. Opposite sides of a rectangle are congruent. I know that BC is congruent to AD. Opposite sides of a rectangle are congruent. And here, I know that AC is congruent to AC because of the reflexive property. It's the same length in both of those, but I have to prove it using reflexive property. So again, that's when you really see it in geometry. Symmetric property, I want you to circle this one. And I want you to put Mrs. Hartman's pet peeve. I only have like 1 or 2. So this is a big one. This is, my language here says if A equals B, then B equals A, okay? Now, when we start solving multi-step equations, like I know you've done, students do this. They'll do 10 minus or plus x equals 15. And I subtract 10 on both sides, and I get x equals 5. And that's perfect, because that's where I want my value of x. I always want my variable on the left-hand side, okay? But let's say we have this, 10 equals x plus 5. Now, to get x by itself, we know we subtract 5 on both sides, and then we get 5 equals x. I do not want you answering like this. I want my value on the other side. So what I do is I say x equals 5. Same value, different sides, symmetric property. So that's my big pet peeve. That's how I want you to remember the symmetric property. All right, last one is going to be transitive property. Again, you don't really see transitive property until you get to classes like logic or geometry. So transitive property, I want you to think transitive. 3 syllables. 3 syllables. In transitive property, there's 3 pieces. So here's what transitive says. It says if A equals B and B equals C, then A equals C. So if you look at that, what you're saying is you're saying A equals B, B equals C. Well, let's throw out that middleman and bring A equal to B. Okay, so it's 3 pieces. If A equals B, 1. And B equals C, 2. Then we bring it together and say A equals C. So, like, for an example, you could say if square root of 49 equals 7, and 7 equals 3 plus 4. Think about what that means. I could say, then, square root of 49 equals 3 plus 4. I can throw out that middle man, knowing that they're already equal, and bring them together. And that's the transitive property. Closure property we're not going to do, so you don't have to concern yourself with that. So now you should have notes for order of operations and properties. If you have questions, come and see me.